Hello again. So today's workshop, we're going to be covering some of the basic science behind percussion therapy and behind the 3dEnergy gun. We're going to be talking about the topic of the 6 whys of physiology. And we're going to be relating that to optimal health and to the chiropractic concept of subluxation. So all of these resources are available on the website, so www.superhealthy.com.au. So there's 2 places you can find all of these resources. First, if you go to the blog page, a lot of these videos are posted there, and you'll be able to watch any material that you're interested in. The second place is to go to the programs, and there's actually a compiled program of all of the video materials in appropriate arrangement so that you can actually follow a more structured program of education. So the 6 whys, we're going to be looking at an acronym, but instead of using the first letter of each word, we're going to be using the last letter. So a little bit of artistic license there. So we're going to be talking about adaptability, the ability of systems to change, flexibility, the ability of systems to have a good range of motion, pliability, the ability of systems to have stretch and elasticity in them, renitency, the ability of tissues and structures and systems to withstand the stresses and strains of life. And we're going to talk about tensegrity, an engineering and architectural principle which applies very accurately to the human structure. Then we'll talk about piezoelectricity, how all of this relates back into electricity and energy and communication. So here's our visual representation of these concepts. So they're all interrelated. Adaptability sits at the center of the wheel. That's what everything else spins around. Everything else is related, interconnected, but separate and distinct. So first of all, we have adaptability. So this is the quality of being able to adjust to new conditions. Can a system change? Here's the interesting thing when we're studying physiology, when we're studying science, when we're studying health sciences, we're taught a lot about this concept of homeostasis, so a static, stable internal environment. So the maintenance of this internal physiological environment keeps us alive in a continuously and at times dramatically changeable environment. So here's the point about homeostasis. In order to maintain homeostasis, it requires massive potential for adaptability from every physiological system. So in order to have stability, we have to have constant change all the time. So there is no homeostasis without constant change. So this necessity exists in every single functional physiological capacity. So this is why this sits at the center of everything else. Without adaptability, we can't survive. So in terms of the neuromuscular system, examples of adaptability are maintaining balance against the effects of gravity. Gravity is trying to pull us down to the ground, but we are trying to stay upright. So there's this change that's going on all the time to be able to maintain an upright posture against gravity. And as a result of that, maintaining ideal posture requires continuous microscopic and macroscopic adaptations in your muscular system, your nervous system, in order to be able to maintain ideal posture. You look nice and straight and stable, but there's a whole lot going on in order to be able to achieve that. So obviously the balance and coordination of movement patterns, so even simple movements require amazing adaptability to be able to coordinate and manage accurate movements, precise movements. So we have this tightrope walk going on in our lives where we're walking straight forwards, but there's a whole lot going on in order to be able to achieve that. The second, we have flexibility. So the ability to move through an unrestricted range of motion. So it's different to adaptability. There is a range of motion in every capacity to adapt, and that range can be diminished or increased in varying states of health. So an obvious example is we can live in hot and cold environments and we can maintain an internal environment, but there are extremes, highs and lows, that the capacity is there. But this can vary between individuals depending on their state of well-being and their state of health. So flexibility is critical for healthy function, critical for healthy movement. Uh, So in terms of the neuromusculoskeletal system, examples of flexibility, we have range of motion of specific joints, obviously. We have range of motion of regions, your neck, your lower back. We have range of motion of muscles and muscle groups. So everything has a range. It has an upper and a lower limit. That's flexibility. Then we have pliability. So don't confuse pliability with flexibility. Our tissues need to be supple enough to bend or stretch, and this is the critical word, to stretch freely or repeatedly without breaking. So pliability is different to flexibility. It's more like elasticity, ability to stretch, the ability of human tissue to stretch under load. So obviously as we age, our skin and connective tissues generally lose elasticity, and this correlates with loss of flexibility, but it's a separate scenario. So pliability is critical for healthy function, ability to stretch and to move. So in terms of the neuromusculoskeletal system, examples of pliability, so connective tissues have a degree of elasticity and stretch in them. Muscle tissues have the ability to stretch and be elastic. So obviously pliability helps range of motion, helps flexibility, but it's a separate concept. Now we have this term renitency. So this was a term used by D.D. Palmer, the founder of chiropractic, more than a century ago, but it's received very little attention since that time. Maybe you can do some homework, some research into this concept of renitency. So it's the abilities of tissues to withstand stress and strain. So you might think that it's similar to resilience. And it's also related to this pioneering chiropractic concept of the limitations of matter. So things can be under stress and strain, but there's going to be a breaking point. That breaking point depends upon the renitency, depends on the capacity. So again, it's a separate component in terms of the intrinsic strength of tissues to not break down under load, whether that's single load, repetitive loads, or sustained loads. So renitency, separate, interconnected concept that's vital for healthy function. So in terms of the neuromusculoskeletal systems, examples are just simply that knife edge between function and failure. Most soft and hard tissues are challenged with throughout a day and lifetime of daily activity. So tissues are always being stressed, they're always being strained, they're always being challenged. Can they withstand those stresses and strains over a long period of time? So renitency, the ability to survive and to prosper in difficult situations. Then we have this idea of tensegrity, which is a whole area of study that's very much worth getting into and researching. So structural stability in tensegrities, so these are particular design styles, depends entirely on tensional integrity or continuous tension against discontinuous compression. So let's explain that a little bit more. The stability of tensegrity structures is due to the way in which their compressive and tensile load-bearing components interact. So they're designed that they are being compressed, but they can withstand that compression due to structural components and flexible components. So here's the interesting thing when we get into biology, that many human connective tissue structures follow the principles of tensegrity. So it's a critical component of health and well-being and good function. So in terms of the neuromusculoskeletal system, examples of tensegrity, most joint complexes are actually designed demonstrating tensegrity principles. Intervertebral disc collagen, for example, arrangements following a tensegrity design. Fascial planes, which surround the body and create the 3D integrity of the human body, often follow tensegrity design principles. So the simplest way to explain a tensegrity is with the picture of a tensegrity model. So we have these solid beams, these structural beams, which are connected by flexible cables. And the way that these are designed is that, number one, creates stability in the system. Number two, it creates flexibility and pliability and movement in that system. And the final point, piezoelectricity. So the electric polarization in a substance resulting from the application of mechanical stress. So the relationship between matter and energy, basically. Tensegrity and piezoelectricity are principles that go well together. One tends to help explain the other and works interactively with each other. So many human connective tissue structures are examples of piezoelectric tissue. So piezoelectricity creates this new dimension. If we just look at these other areas, then we're really just talking about a Newtonian mechanical system. Once you get into the piezoelectricity, you start to understand the energetic and the electric components and the communication component of health and well-being. So in terms of the neuromusculoskeletal system, examples of piezoelectricity are, so the bony lattices follow piezoelectric stimuli for the organization and reorganization of their configuration. So calcification and decalcification is all driven by the piezoelectric currents going through the bony structures. Connective tissues, which generate piezoelectric currents under stress and strain, this has been found to be helping with biofeedback, communication, proprioception. So never forget that the human biology system is energetic, it's electric, that relates back to the mechanical. So once again, we end in our 6 whys. We have adaptability, the ability of a body to change, to respond at microscopic and macroscopic levels every minute, every second of your life. We have to have flexibility. We have to have range of motion in every aspect of our lives. We need pliability in all of our tissues. We need stretch and elasticity to be able to maintain good health and good function. We need a system that has renitency, that has resilience, that has strength against the stresses and strains of life. Then we need a system that's so intricately designed that it has all of these things are built into the design. The stability and the flexibility go hand in hand. And as we said, finally, we need to connect that all into electricity, into energy, into communication, into biofeedback. That all requires piezoelectricity. So our diagram again, just reminding us how interrelated, interconnected, and coordinated all of these systems are. So how does this relate to subluxation? So as we said, the functional and subsequent changes in the CSMFU, the craniospinal meningiofunctional unit, is the unit of the spinal system. So we can have a loss of adaptability in that system, loss of its ability to change and respond to the stresses and strains of life. We lose flexibility either locally or globally. The system becomes less pliable and elastic, it becomes harder. And it loses its resilience, its renitency. We start to get injuries, we start to get inflammation, we start to get acute flare-ups. And then the disruption of tensegrity. If you remember that model, if you interfere with any one of those cables, any one of the flexible components, it impacts the entire system. And obviously an interference to piezoelectricity. This is the chiropractic foundational concept that spinal dysfunction leads to neurological dysfunction, leads to energetic problems, leads to problems with communication. And then similarly in terms of health. So functional subsequent changes in physiology that are trying to maintain homeostasis, if you start to interfere with those, then you have an inability to respond and cope with the stresses and strains of your environment, either externally or internally. So you lose adaptability. You lose the ability to maintain your homeostasis. You have reduced flexibility to the extremes of life. There's less pliability to stretch and respond to everything that's going on around you and within you. You have diminished renitency, diminished capacity, diminished resilience to withstand the stresses and strains of life. And then your tensegrity, your design of your system, starts to be impaired, to be interfered with. You lose integrity of your structural and functional systems. And obviously this impedes with communication. Once we start to lose communication, we start to lose the ability to heal and to regenerate and to live a good quality of life. So once again, you can find these resources on the superhealthy.com, either on the blog page or on the programs page. Or you can even go to my YouTube channel. A lot of these videos are there. So it's a Super Healthy channel, healthy without the A, and you can watch more of these resources. So we'll see you in the next workshop.